Already 15 seconds late. Good morning, everybody. Thank you for coming out on this rainy day. Look at the bright side. It could be ice or snow. It should be this time of winter, but I wonder if it's global warming. No such thing. All right. One thing that's been sort of interesting and frustrating at the same time is getting my videos out. We're having trouble getting it on the school system. So, as in all things in life, you take 2 steps forward and 1 back, and that's life. And if you go to your favorite search engine, and put in right, class CHEMI 1212, and then my last name. And through the magic of Google, you'll see there's some lectures up. Now, unfortunately, when I did it last night, the quality of the lecture, I'm now a superstar. I'll be selling pictures and other things tomorrow in class for an exorbitant amount of money. But, let's see if it looks on my, well, it's not too bad. You get close enough to the monitor, you can see what I'm writing. And there I am. So I'm going to sit down and let you watch. It's not time for summer reruns yet. But I'm going to be getting them all up there. I have 4 of them up there right now. And as you can see, 6, 7. The way I have it is you'll see the year, the month, and the day. And then I have topics covered here. So it's coming along. I never thought I'd get this far even. So, good news. All right, let's get the better stuff. Let's get back to ketones and aldehydes. Better shut this down. And we started on ketones and aldehydes. And remember, carbon double bond to oxygen with carbons and a hydrogen is an aldehyde. Carbon double bond to oxygen with 2 R groups is a ketone. One of the most important parts of organic chemistry to me, and now I'm extremely, extremely biased, is the carbonyl group. And the carbonyl group, which you should know how to draw and also put down with words to describe, carbon double bond to oxygen. And if you notice, both aldehydes and ketones have carbonyl groups. Aldehyde, find the longest chain with the carbonyl carbon, drop the E of the alkane name, add Al, no number. Ketone, find the longest chain or ring with the carbonyl carbon, and name it as an alkane or cycloalkane, drop the E at the end of the alkane name, add ONE for acyclic, you'll need a number. We went through this yesterday. Now, there are many common names, both for aldehydes and ketones. There's a whole system of common names for aldehydes and ketones going up to 10 or 11 or more carbons. I'm just going to ask you to learn 2 simple ones. And these are very important in our daily life. Now, it turns out in aldehydes, R can also be a hydrogen. And when that happens, the simplest aldehyde you can have in nature is this compound. Nobody ever calls it by its IUPAC name, methanal. No one does. It's called formaldehyde. And formaldehyde is a very important chemical. I worked for a company years ago called Borden Chemical, which since got bought into conglomerates now called Hexion, which it was and still is the largest producer of formaldehyde in the United States, if not the world. And Formaldehyde is used in many things. One of the most important things is to make what's called a resin. A resin is a fancy name for glue. And where do you use the glue? To hold wood together. Underneath this veneer, and that is particle board, plywood, or oriented strand board. I don't know if I can see which. It's more like plywood here. Thin sheets of wood glued together, and that makes plywood.
Is that the same formaldehyde?
What?
Is that the same formaldehyde for embalming bodies?
Yes, they do that too, but I don't get into that. That's not an area I really worked in, not plan to. But the answer is yes. It's also a, what would be the right word, used for biological specimens and everything to keep them from decomposing, I guess. It's a biocide, bacteria, and it's also quite hazardous. Now, formaldehyde, for many years was blocked by a certain senator who was paid by certain rich industrialists who blocked the EPA from listing it as very hazardous. It's a carcinogen, mutagen, a lot of these bad things. And unfortunately, if you make wood wrong with the wrong resin, too much formaldehyde, it can be very, very dangerous to you. And I'd like to talk about something, this won't be on the test, but it's something I feel as a responsible organic chemist I should talk about. How many of you remember many years ago, I assume you're old enough to remember, Hurricane Katrina? It was about 2004, 2000, somewhere around that time frame, a while ago already. And the horrendous storm that hit New Orleans and all around in that area by the Gulf there, killed a lot of people. I still remember people trapped at the Superdome and our then head of FEMA and the president did nothing for a couple of days. That was a national tragedy. And it destroyed so many homes that the government had certain companies in the United States built very quickly a lot of trailers so people could live in them. Well, before the hurricane, people were getting plywood and wood to cover their windows and all that, so there was a shortage of plywood in the United States. This is not publicly known, and this is my conjecture also. This is true, and this is publicly known. People who started moving into those trailers and lived in them started getting sick. Some of them very sick. Their pets would die. Their older people had very bad illnesses. And there was a very brave woman named, she's still alive, very much alive, Becky Gillette, who worked for the Sierra Club or Sierra Club member, with her own money, got some test kits and tested for formaldehyde in these trailers. And they were super hot, and that's what was making the people sick. Well, the government, FEMA, EPA under George Bush, W. Bush, and the president himself at that time, Bush, disputed Becky Gillette and said she's wrong. And they went and did tests and found out, no, she was right. And these caused these toxic trailers. Around that time when I heard about that, I was teaching and I was also a consultant and also an expert in formaldehyde. I contacted Becky and said, free for you to use any way you want. And I wasn't the only scientist who was helping her. At her urging, I then wrote the new president, Obama, and the head of the EPA, about how to change the law so this wouldn't happen again. I and other chemists and scientists, a lot of groups were able to enact the law. But what it means is you have to be careful. If you buy anything from any wood product that's not solid wood, especially if it was made in China, it can give off a lot of formaldehyde. Through Becky, I talked to a woman who had a service in California who goes into her homes and tests for formaldehyde. And she had a number of very wealthy customers who did things like put in a $50,000 remodeling of their kitchen. The cabinets came from China. And their kitchen was now badly exposed to, or the people in there, to formaldehyde, which got them sick. So what do you do Well, one of the nice things about this website, if you ever want to contact me by email, even if you're not my student anymore, you'll see this place right here where it says test for formaldehyde. And I've had a number of students and other people here at COD and ECC buy these kits. And this is the company, FEMA and the EPA tried to prove was wrong. And all they could prove was it was very accurate, good company. And for about $40, they'll send you this little badge. You put it in, or a circle, you put it in the room, take off the covering, let it sit for 24 hours, put the covering back on, mail it to them, they give you a mailer, and they can either email or US mail the results and tell you it's above a certain limit or not. And it works. About 2 summers ago, 60 Minutes did a beautiful, amazing story about a company called, I think you might have heard of them, Lumber Liquidators, get the name wrong sometimes, and how they were having products, and this was, the laminated floors that look like very fancy wood floors. It's really plywood with a little veneer on it. And it was made for them in China, and how they were able to sell it so cheap compared to everybody else. The Chinese company wasn't following the new law and keeping the formaldehyde level down. When you don't worry about the formaldehyde level, it's cheaper to make. And 60 Minutes exposed the company, both lumber liquidators, because they got some of their products sold here in the United States and like Chicago, tested it and found, whoa, it's too high in formaldehyde. Then I let the faculty and staff here and the other school know. I couldn't send out an email to all students here when it happened. So, formaldehyde, used properly is good, not used properly is bad. A couple years ago in the Chem 1212 class, when I talked about this, a student asked me, have you heard about this hair treatment called Brazilian blowout? I said, no, and I looked it up. And when I looked it up, I found out within a week before I looked it up, the Oregon and the California EPA had issued warning because they use excess formaldehyde in this product to straighten your hair if you have real curly, fussy hair. And that was making the operators who were doing it sick and the people who said it done sick. Formaldehyde is dangerous. But like I said, I worked for it my last patent. I used formaldehyde and I know how to use it properly. Anyways, just wanted to warn you about that. And what that means is, especially, anybody who's got a newborn, what they normally do if that's their first newborn is they go out and buy new furniture. And if it's not solid wood, I would have that room checked for formaldehyde. All right, let's move on to something else. Another compound I would like you to know the common name for is this one. It's a ketone. IUPAC name, which nobody ever uses, is 2-propanone. 3 carbons, propane, drop the E, O-N-E, it's on carbon 2. Nobody calls it that. Everybody calls it acetone. You know it for the stuff you use to clean and dry your glassware in the lab. It's one of the 2 chemicals, I'll teach you the other one later on, that's used as nail polish remover. For a number of years, if you go to Walmart or other big stores, the other chemical had the most shelf space, but it's changed in the last year or 2. And part of that is because you people probably know much more about it than I have, too, because students told me about it. That is, the new super hard nail polish doesn't come off well with the other one, comes off nicely with acetone. Oh, by the way, nail polish is really sophisticated, high-level organic chemistry. See, organic chemistry is everywhere, even on your fingers if you have nail polish. All right. Now, a couple quick things. And some of you had lab learned about this yesterday, and those of you who have lab tomorrow will learn about it. Ketones and aldehydes are found in nature. Benzaldehyde, those of you who had lab yesterday, you smelled it. Those of you who have lab tomorrow, you'll smell it, and I won't give away what it smells like. Cinnamon aldehyde, I wonder what that's in. Oh, I'll give it away. Cinnamon, that's what cinnamon makes cinnamon. Vanilla is an aldehyde, and raspberry ketone, which was a sort of common name, is, guess what, a ketone. And you don't have to know the structures of these, but it's good to know, why are we learning this stuff? be right back to that slide in a second. Maybe more than a second. And here we have a ketone. On the internet, you'll see they use the whole line method. Every bend in the line is a carbon, every end of the line is a carbon. So here I have a ketone, carbon, carbon, carbon. It's got a benzene ring with a hydroxyl group. How Mother Nature came up with this, I have no idea. How my body knows when it's on my tongue and tells my brain, ooh, this is raspberries, do you like that taste? And that causes the taste and smell of raspberries. It's a ketone. It's actually an aromatic ketone. So next time you're in the produce section, and fruits and produce section in the supermarket, what you smell and a lot of things what you see is due to organic chemistry. All right, now the next couple of functional groups, I'll be doing the same thing. Introducing you to a functional group. Hello, here's the aldehydes ketone like I did. Go through the nomenclature of how you do that, where you find it in real life, then how do you make it, which is important, and then the fun part, how do you react to it. All right, I'm going to go through this quickly because I've already done this in alcohols. Take a primary alcohol, oxidize it, you remove the hydrogen here, hydrogen there, form a carbon-oxygen double bond, and you get an aldehyde. Since I've done this reaction in alcohols, I'm just going to do two examples, and I'm going to let you try it. And the question would be, what's the organic product or products that are following? For those who came in late, you missed how to find me on YouTube, videos of this class, and I'll go through it again tomorrow. But just go to Google and put in Chem 1212, my last name. Hopefully within a week or two, I'll only be a day or two behind in my lectures going online. So you can get instant replay. Remember, play it a lot of times and click on the ad so I maybe can get some money. I'm not holding my breath on the money part. All right, let's take a look at this. What's different? You've heard me say that before, and it's true. When I look at a molecule, I look for what's on carbon, hydrogen, what's on a carbon-carbon single bond, hydrogen with an oxygen with a hydrogen, hydroxyl group on a carbon, and this is a primary alcohol. Here's my R group. Let's ever attach the C2OH. This is oxidation. I'll lose the two hydrogens here and form a carbon-oxygen double bond, and what's ever attached to this carbon comes along for the ride. 3 carbons, better end up with 3 carbons. Here's my R group. Here's carbon double bond to oxygen. And that's the molecule you get. Now, on test number 2, like test number 1, not 1, but 3 synthesis problems. And the question would be, what's the starting material for the following? Why don't you try that, since we've already done these in alcohol. All right, looks like the last hydrogens like this, about done. All right, let's take a look at this. And the question is, what functional group do you see in this molecule? Which is another way of saying what's different. Carbon double bond to oxygen with a hydrogen. And our group, what are we doing? We're oxidizing something. What do we oxidize to get to that? A primary alcohol. What's my R group? That. And therefore I have 4 carbons across. Because notice I'm not adding any carbons. Then right here I have 2 methyl groups. Here's my carbon. That's the carbonyl, which becomes this carbon. So I can do this. And then put in the hydrogens. And that's how you do synthesis problems. That's the fun part of organic chemistry. I need to make this, how do I make it? If you can do that to primary alcohol, we've already covered this, you can also oxidize a secondary alcohol. And again, since I did this, we went through this in alcohols. I'll do one example here, better yet, let you try one. Again, the general reaction is take a secondary alcohol, 2 R groups. They can be the same or different. That's why we use R and R prime. And oxidize it, lose these 2 hydrogens, form a carbon-oxygen double bond. And now we have a ketone. As I said yesterday, as I warned Dr. White Monday, Dr. White loves ketones and aldehydes at the time. And I've run these reactions. To make ketones and aldehydes, I need to work with. And why don't you try this problem, which is give the organic product or products that follow. I hate to break it to you, you're doing organic chemistry, some serious organic chemistry. Doesn't it feel good you can do it? All right, before I do this problem, I have a homework assignment for all of you if you want to do it. And that's between now and tomorrow, if you have a chance, go on either your cell phone, your laptop, your home computer, or your tablet. Go to Google, put in the course name, CHEMI 1212, our last name, and look at the video for either on 2017, 02, 08, or 09, and look at the board. Can you read it well? Let me know tomorrow. I'm just curious. All right, let's take a look at this right away. Hopefully you can see me. Not go to the optometrist. Now, let's take a look at this. Question is, what's the product or products that you do when you react this? By oxidizing it. What is this? Carbon with a hydrox group, carbons here and here, secondary alcohol. Oxidize it, you get a ketone. I can call this R and this R prime, and they're just connected together. And what that really means is, do you break carbon-carbon single bonds? No. So I have my ring with the methyl group, which carbon has the hydroxyl group? This one, which is this one, which is this one, which means they'll now have carbon double bond oxygen. And that's how you do it. What would I have to react by oxidation to make the following molecule? Boy, I'm making you work hard today. Did I pass around the sign sheet?
Yes.
Yeah.
Ah, I see it. Came in late, I'll be up here. All right, looks like everybody's done. Let's take a look at this. And the first question is, what functional group is in this molecule? An oxygen double bond to carbon. Carbon's here and carbon's here. I'll call this R prime. Doesn't matter which one you call R or R prime. It's a ketone. When do you oxidize? To get a ketone, a secondary alcohol. Therefore, if I look at this carbon, which came from that carbon, I'll have this. What's R? Methyl. What's R prime? 3 carbons and propyl, if you want to call it that. And that's your molecule. And you could have also drawn it this way. And that's how you do it. And that's 2 important ways how to make alcohol. Take alcohols, make them into aldehydes or ketones. Now, I'd like to talk about a very special reaction. Why is it special? It's one of those rare times when you can make a carbon-carbon single bond. Very special. And this is named after Friedel and Krauss. Yes, you learned about another one of their special reactions. And this is similar. And this is called Friedel-Crafts acylation. Now, I'm not going to ask you to learn this, but in organic chemistry, this is called an acyl group. Carbons on a carbonyl bond to something. And what this reaction does allows you to put an acyl group on a benzene ring. And similar to Friedel-Crafts alkylation, instead of this being an R group, this is now an acyl group, and you have your benzene ring. You need the aluminum chloride. This is an electrophilic substitution. You replace one of the hydrogens with the acyl group, and you make this special type of ketone. And you made a carbon-carbon single bond. These are called aromatic ketones. By the way, it's a functional group I don't have the time to talk about this semester. It's called an acid chloride or acid halides in general. Let's take a look at this reaction. And the question is, what's the organic product or product? And now we have to identify what's different. And if you look at this, ooh, benzene ring. That's different. I know it's aromatic, not carbonyl with a chlorine. This is called an acid chloride, an aluminum trichloride. This is Friedel-Crafts acylation. And what I get is my benzene ring, a carbonyl, and then what's my R group? In this case, methyl. And that's how you do it. And why don't you try this one? What would be the organic product or products of the following? Those who are quicker to finish early, try this. One finger goes forward, the other gets backward. When you master that, do it with your thumbs. I'm terrible around little kids. All right, let's take a look at this. What do we have that's different? Ooh, benzene ring. What's different? Ooh. Carbons to carbonyl to halogen, chlorine, and the catalyst, aluminum trichloride. And what happens? You get Friedel-Crafts acylation. I'll make an aromatic ketone. What's my R group here? 2 carbons. And therefore, what do I get? Benzene ring, carbonyl. And what's my R? 2 carbons. And you made that aromatic ketone. Oh, this is fun. Let's try a synthesis one. And I'll do this one because it's a little challenging. And the question would be, what 2 things do you react to make this? And the first question is, what's this? Oh, it's a ketone. Carbons here, carbons here. And I could say one side has a benzene ring and a carbonyl, I could say that's a benzene ring, and that doesn't help me, but if I say that's an R group, it's got carbons and hydrogens, then I know this is for real crafts acylation. And if that's the case, what's one question mark? Benzene ring. What's the other question mark? This asks the chloride, what's R, a benzene ring, carbonyl, and chlorine. And you'll get that. Now, why did I pick that? Well, I had a reason. And that reason is, I've said it a number of times in the last couple of days, when you're taking this course, you should ask yourself, why am I learning this stuff? Why is organic chemistry, important to my daily life? The compound we just made has a common name called benzophenone. I'll never ask you this on the test. Benzophenone is used in photochemistry. It helps start reactions when it receives ultraviolet light. How many of you have seen or have used the nail polish that when you put it under light it hardens? That's using a photoinitiator, an aromatic ketone, maybe benzophenone, maybe others. Now, another thing, when you have a lot of pi bonds conjugated together, and it's called aromaticity, it has an ability to absorb UV light. And where's that important, absorbing UV light? Where's that? Oh, my skin. Sunlight, UV light causes cancer, damage to your skin. How do you stop that? Use sunblock or suntan lotion. How does that protect your skin? By having aromatic ketones like that. This is one of the ketones that was used. They've gone to one now that's safer, where the benzene ring has things like methyl groups on it, substituted. And that's the sunblock. They say it's this sort of, what's the term? Sunscreen level or something, 8 or 9. What is it called? What? Louder. Thank you. SPF value. It's due to this molecule or molecules like that. So let's think about it. You mean my sunscreen or my suntan lotion involves organic chemistry? You better believe it. Big time. Also, other things, reactions you don't know about, like in terms of printing. There's certain types of printing. You put it on the ink on the paper, and you use the UV light to cure it. And that's using aromatic ketones like benzophenone. So in this summer, when you're putting on your suntan lotion, remember, that's an aromatic ketone protecting your skin. And question B, what's the starting materials for the following reaction to make that product? And test number 2 will have 3 synthesis problems. By the way, any of you who have your hair up in a bun on top, you can see it in video. You can see me too. And this weekend, I'll be at the local shopping center signing autographed pictures of myself. Star is born. Uh-oh, it's getting to my head. right, looks like everybody's done it. Let's take a look at this. And the question is, what are the starting materials? And as a public service on test number 2, which I don't have to do, and I took a course my instructor didn't do, is I'll show you there are 2 things. I won't just leave it blank. If it's blank, that means there's only one thing you have to put there. All right, what do I react with aluminum trichloride to make this compound? Well, what's this compound? Oh, carbonyl, carbon's here and here. It's ketone. It's an aromatic ketone. And how do I make aromatic ketones? React benzene with an acid chloride. And therefore, one of these question marks, and it doesn't matter which one you push first, is a benzene ring. What's my R group? What's ever attached to a carbonyl carbon? Carbon double bond to oxygen. And therefore, it's 3 carbons. So R is 3 carbons. Then I have a carbonyl and a chlorine. And I know how many hydrogens to put in because of this. And therefore I'm done. And that's how you make aromatic ketones, which, like I said, are used heavily. I've never looked it up because it's not an industry I've worked in, but I wouldn't be surprised if the nail polish we put under UV light to cure probably has aromatic ketones in it to help it cure. That's a whole area of organic chemistry I won't get into. I could do a 2-semester course on what's called photochemistry. All right. Now we're getting into the fun stuff. And that's reacting ketones and aldehydes. And if you had your book and were reading it, which you don't have to, but you see that the authors came up with part 2 of the carbonyl group. Now, what's the carbonyl group? You should know. Carbon, double bond to oxygen. Well, double bond, you know this. What is it made up of? 1 pi bond and 1 sigma bond. But unlike carbon, I can break both of those. Carbon-oxygen pi bonds, I can break like that. And I can almost break like that, carbon-oxygen sigma bonds. Now, another important thing about the carbon-oxygen double bond in a carbonyl group is that it's polarized. If we come over to the periodic table, you'll see carbon is right here. And to the right of it, over here, is oxygen. And when you go this way in the periodic table, elements are more electronegative. What that means is they're sharing electrons, but if I'm more electronegative than you, I'm stronger than you, and I can share the electrons closer to me. It's sort of like if you had an older sister, and you were out in a rainstorm, and you only had 1 umbrella, yeah, you share the umbrella, but it's more over her. True story, don't tell my sister I told you that. All right, so anyways, what that means is the bond is polarized. And what polarized means is, in a carbonyl group, unlike a carbon-carbon double bond where they're both the same element, the carbonyl carbon is slightly positive, the oxygen is slightly negative. And this means you can have what's called nucleophilic attack. I think I warned you, organic chemists are very violent. We talk about bonding, we don't call it bonds, we say it attacks. And if I'm a nucleophile, ooh, that's a new word for you. Time to learn a new word so you can impress your friends, neighbors, and loved ones. Let's look at nucleophilic or nucleophile. What's the word phile mean? Well, lover. What's nucleus? Ooh, that's the center of an atom. And what charge is on the center of an atom? Well, it's got protons, no charge. Protons have plus charge and neutrons, no charge. So it's plus. So a nucleophile is something that's looking for plus charge. And if I'm a nucleophile, I love plus charges, carbonyl carbon, I'm going to attack that because it's slightly positive. And a lot of the reactions, that's what you're going to be learning about. Next slide or two switches in the off position, click. All right, what this means, nucleophilic attack, is you have something called a nucleophile. Sometimes it has a negative charge, sometimes it doesn't. And it will attack, bond that, break the pi bond, and the electron from the carbon here goes to the oxygen, so it has a negative charge. And you make a new single bond. And in some cases, carbon-carbon single bond. That's very rare and very fun. Very fun. Lots of fun. Another way of showing it, you have a nucleophile that's H plus, Nu minus. The Nu nucleophile attacks the carbonyl carbon, is slightly positive, breaks the bond open, and the H plus goes to the oxygen. All right, can I have everybody's attention? The next 4 reactions are some of the most challenging for students this semester. So everybody take a deep breath, relax, take another deep breath, relax. If you're having a little difficulty with the next 4 reactions, you'll get it. Now, why am I telling you this? Because it's true, so you won't feel frustrated when you're having some difficulty. But why are you learning this? Because it turns out the next 4 reactions Mother Nature uses to make carbohydrates, and Mother Nature uses, and you use, to break down carbohydrates in your stomach. So are they important? I would say so if you like carbohydrates, which helps us stay alive. And later when we get into carbohydrates, we'll be coming back to these reactions. And they all involve nucleophilic attack on the carbonyl carbon. But again, these are going to be challenging, but I know you're up to the task. You can do it. I have faith in you. And I'm going to let you out a whole minute early so you can start this question tomorrow morning. Those who have that tomorrow, don't forget to bring your to-do list. Don't forget, if you have a chance, look at my videos online and tell me what you think of the problem. There's some on the board on